So with this example, we have 6x plus 2 divided by x squared minus 1, and that rational expression is divided by 3x squared plus x all over x minus 1. So the first thing we want to do is factor our polynomials. So I'll make my fraction bars, show my division, there's my other fraction bar, and then go to town. So the numerator here, 6x plus 2, it seems like the greatest common factor is just going to be 2 because 2 goes into 2 as well as 6. So I say to myself, 2 times what makes 6? That's a 3. And I didn't factor out x, so it's still there. And then 2 times what makes positive 2? That makes a positive 1. So I can quickly check it. 2 times 3x is 6x. 2 times positive 1 is positive 2. And then the denominator, I notice, is the difference of squares. So that factoring would look like x minus 1 times the quantity x plus 1. It could also be x plus 1 times x minus 1. It doesn't matter the order of those factors. As long as you have the same term at the beginning of the parentheses and at the end, and then they have opposite signs. So on to the second fraction, 3x squared plus x. In this binomial, we only have x as the common factor. So I'll factor that out. So x times what makes 3x squared? It's plain old 3x. I can double check that. X times 3x is 3x squared. And x times what makes positive x? Well, it's the same, so that will be positive 1 as our answer. And then the denominator, x minus 1, is already all by itself. I'm going to put some parentheses around it, though, so that I'm reminded that it's a factor, and I don't try to do anything funny like cancel out a single x or the negative 1. So our second step for the rational expression division is that we want to invert and multiply. So our first step was over here to factor. Our second step, we always take the second polynomial here, the second expression, and that fraction is going to be flipped, inverted, and then when we do that, it turns into multiplication. It's our shortcut way of looking at division when it's side by side. If you had vertical division, you'd have to get rid of the denominator, and you do that by inverting, which turns into multiplication. So we'll just rewrite our first rational expression. Nothing is changing with this guy. But now we're going to write a multiplication sign, and then our second fraction is going to be flipped. So x minus 1 was on the denominator, but it will go on the numerator now. X times 3x plus 1 is now on the denominator. So I've inverted and multiplied, and if I wanted to, I could rewrite all of this onto one giant fraction bar. It looks a little bit cleaner like that, but we can also, at this point, start canceling out our similar factors. Cancel factors that we'll see on the numerator as well as the denominator. So when I do this, I notice that there's a 3x plus 1 and a 3x plus 1 on the numerator as well as the denominator. So like we saw in the video when we were multiplying rational expressions, when you had the same factor on the top and the bottom, because the fraction has the same numerator and denominator, when you divide them, you always get an answer of 1. So by canceling out, we are essentially converting our factors into lookalikes of 1. So here's another one that's similar, x minus 1 and x minus 1. And then anything else, Well, there's a 2 on the numerator, and there's not a single 2 down here. There's no x plus 1's running around. There's no plain old x's running around. So what is left over is the 2's left over, and the x plus 1 is left over, and the plain old x is left over. Writing that out, we get an answer of 2 divided by x times the quantity x plus 1. So it's okay to leave our answer just like this. You don't have to go the extra mile and say, oh, well, that's going to be x squared plus 1. I'd rather not see that. This factored form is easier to work with. If we had to do something else after this point in time, we're already factored and the problem is easier to work with. We don't need to refactor to continue on doing any more steps. So there we go. In this example, we have divided two rational expressions by first factoring and then inverting and multiplying. We canceled any common factors, numerator to denominator, and then we rewrote our answer in simplified form.